right, well, cool, welcome. When we were doing all of our going through the code adoption and going through all of the things, this is one of the requested classes that we had. We brought thermal bridging into the residential requirements. So we want to talk about that. What does that look like? What do we need to know? And touch on some things on continuous insulation that seem to be, I don't know, a mystery to people, I guess. I don't know. So we'll just go through it. We're going to talk about what is continuous insulation, when does it become not continuous insulation, because that's pretty easy. What are the different types, benefits, how to use ES reports when we're talking about those, because continuous insulation can be used as many products in one building, so we want to make sure that we're using those ES reports to verify. How does it work for wildfire resilient construction? And then we'll get into thermal bridging. What is that? How do we mitigate it? And then I have an amazing amount of resources for you. So when we get done and I send you your CEUs, I will also send you a file of so many resources. We'll go through them and I'll touch on them today. But in 2 hours, there's no way to get you every detail and everything that we should think about. So I have backed it up with a ton of resources for you. So you'll be getting a lot of stuff. So, all right, let's just jump in. Sometimes we think we know what continuous insulation is, but the Energy Code is really good about defining things. And sometimes we don't read those definitions, and so we miss the mark. So I want to just make sure that we understand the definition in the Energy Code for continuous insulation: insulating material that's continuous across all structural members without thermal bridges other than fasteners. What is a fastener, right? And surface openings installed on the interior or the exterior or integral to the opaque surface of the thermal envelope. So we're continuous insulation over the framing, across the structural, not within it, right? But I want to point out this fact, is other than fasteners, what is that? So a fastener is not like a Z-channel or those kind of things, right? A fastener is like a screw or something. This is kind of hard to see this picture. But so you might have, there's different ways to screw the insulation. This is in one of the resources I send you. I don't know if we can shut this first row of lights off or something, if it would show up better, but you know, you can screw through your cladding into the insulation, into the framing. You can screw through the cladding into a furring strip. You can screw through into a channel. All of those are fasteners, right, that are not actually that they might have a little bit of a thermal bridge to them, but they are still allow the insulation to be considered continuous. However, if we go this route, then we are ending up with a thermal bridge. Right now, if we do these channels, we end up here with cavity insulation. So if I was looking at this and trying to evaluate the R value or the U factor of my wall, or I was doing a res check or something, I'd have probably a cavity insulation on the inside of the building and a cavity on the outside. I would just add those together. So if I had an R20 in this inside and an R5 on the outside, I would have an R25 versus an R20 plus 5, which is very different, right? And so we have to make sure this is not a fastener that allows it to be still called continuous. That breaks it up. That is a thermal bridge that now makes it cavity. Right? So just want to make sure that we're clear on that. We just have to calculate the U factor or the R value of the wall differently when we do it that way. The IBC also covers this in Chapter 14 when it talks about foam plastic insulation and how it has to be sealed. It's very clear that Z-furring turns it over into cavity insulation and not continuous. This is probably going to be your best friend right here, this link down here to continuousinsulation.org. I probably go there every single day. I'll make sure that you have that link. We're going to use a lot of the resources out of it. If I get done in time and I don't talk too much, we'll actually go through the website because it is an amazing website with so many resources, calculators, everything in there. So I'll be referring to that a lot today. All right, let's think about insulation. I get this question a lot, or I do a plan review, and the designer is saying, well, this is continuous insulation because it's rigid foam board. Is rigid foam board continuous insulation? It can be, but can it also be cavity? Right? And so it's not, what makes it continuous is not the product, and what makes it continuous is the install. And I think that gets a little bit confusing too, right? So I could have a rigid foam board that's installed continuously over the top of all the framing. Now I have continuous insulation. I could take the same board, install it in a cavity, and I have cavity insulation, right? I can take a bat of insulation and have it be cavity, or I could also hang it continuously and have it be continuous. So I get that confusion a lot over cavity versus continuous. People automatically think a certain type of insulation is cavity versus continuous. I will say it's really hard to get a continuous insulation in a spray foam, right? Because no matter where you're spraying it, there's some framing, and you're going to have to go over that framing with the same thickness in the cavity to get that R value to make it be continuous. Who's going to do that? All right, another thing I want to show you, I do a lot of residential field studies, commercial field studies, to go into buildings while they're under construction to see, how are people complying with the code? What are they understanding, not understanding? Where do we need more training? And I notice this. The code says insulation has to be labeled for its R value, and that's great. I noticed that this house, I think this was in New Mexico, had installed this continuous insulation on the outside of the building, but when you get really close up, I just want to point out, especially code officials, when a designer says, I'm going to do an R20 plus 5, and they just say, I'm going to use EPS or XPS or polyiso or whatever, each one of those insulations has a different, model, a different version of the insulation, and each one of those has a different R value based on the temperature and the climate that it's being installed in. So yeah, this insulation can get to R5, but only this specific one in this specific cold climate. Right? So you just want to make sure that you're looking, the colder it is, the more it resists, so you get a better R value. So just making sure that you're looking at those values. The energy code we'll see here, in the energy code it tells you when you're evaluating R value, you have to do it at the 75-degree temperature. Right? So if I go back here, the 75-degree temperature, I'm only getting that 4.4 instead of the 5. Not a huge difference, but if I'm trading some stuff off and I'm just passing by 0%, it might not be the right number, right? So just something to keep in mind. All right. So also in the energy code, it does give us this. There's a lot of formulas out there for verifying R value, right? Everybody has one. It's like, let's pick one. Never going to ask you to memorize a calculation like that. All I just want you to know, it's in there, in Chapter 3, where all of our install kind of guides are in Chapter 3. Nobody ever goes to Chapter 3 because they think it's only in there for climate zones. But there's a lot of stuff about insulation in Chapter 3. And it tells us that we have to use the specific Title 16 formula for R value. Why do you care? Because if for some reason you want to propose an alternate design, it would be upon you to prove to the code official that you've met the intent of the code and that you're whatever it is. I've seen When I used to teach, I would say there's this mushroom insulation that these guys made. Like, how do I verify R value? It's upon the person applying for the alternate to prove that you've calculated R value to this one, because that's what every other insulation in the code had to calculate to, right? So just something there. There is this whole thing on siding, vinyl siding. For many code cycles, Matt Dobson, the vinyl siding guy, and I fought at the code hearings because I didn't think vinyl siding, insulated vinyl siding, should be allowed to be considered continuous insulation, just because there's just a lot of things about it, that the way it's installed, the air movement, the different levels of insulation, that it shouldn't be considered that. However, in the 2024, it made it into the code as a continuous insulation with some caveats. So the R value is on the package. It's not anywhere on the siding. So you always want to make sure you're seeing the package for the insulation so that you know it's usually around an R2 or an R3. R values are determined according to a different calculation, and then install according to manufacturer's install instructions. There's a little bit more on that, so we'll look at it. A couple other things on insulation that we need to know about is that, yeah, you can add layers, right? You can add layers to, I could have some spray foam. We see a lot of that flash and bat type of situation where we spray some foam in the cavity to get the air tightness, and you can get a couple R value out of that, and then we come in with a bat on top of it. So I might have an R2 and an R19. I've got an R21 in there. That's allowed. You can add layers as long as there's not air movement between the layers, right? So I couldn't add a bat on the ceiling of an attic and then spray foam on the roof deck and count them together, right? Because I have a whole attic of air between them. But like this, I could add those. The other thing it says, when I have install insulation, I have to use the settled R value. The settled R value, we know insulation settles when it's blown in. That settled R value is what has to meet the code, right? Not what it is when you install it, but what it will be when it's settled. It has to meet the R20 or whatever the requirement is, okay? And then insulation shall not include the R value of other building materials. When we're going prescriptive, you do not get to count the air film and the drywall and all of that. You only get to count the R value of the insulation. If you want to count all the other layers, there's a pathway for that. But here's what I want to point out is in 402, under the specific insulation requirements, because insulated siding got brought in as a continuous insulation, like you could see, right? The level of insulation changes. The install is not 100% airtight. There's going to be air movement. So the code now says, if this package would have said this comes in at an R2 continuous insulation, you're only allowed to count it as an R1.4 because you have to knock off 0.6 from it, right? Because of the way that it gets installed and it's not perfectly R2, right? So just want to point that out if you're counting on that for part of your continuous insulation value. Can you use vinyl siding anymore once this wildfire code comes out? Yes. Yes, you can. We're going to look at that today later. Or
I wonder if the popularity could increase because of that. It's not very popular in Summit County, but
yeah.
I wonder with the wildfire codes now having to be followed, if that could become...
I don't know, because in order to use it, you have to either use your, everything else has to be, well, we'll look at it. I have a whole slide on it, on continuous insulation meeting it, but I don't know, because you have to build a 1 hour rated assembly or a fire resistant, or not fire resistant, it's the wrong word I'm looking for, but you have to build a pretty whatever in order to put that siding on there, so maybe. All right, here's the different kinds of insulations that we see out there for mostly for continuous insulation. This is just some of them. This is more of your rigid foam boards, right? XPS, we see that a lot of times used in exterior walls, but a lot of times below grade. A couple things I want to point out. It's good. You can use average about R5 per inch. You can, like we've seen, we can get lower, we can get higher. It's about mid-range in price between the polyiso and EPS. It is slow to absorb moisture, which is really good. The problem with this one is that it is also slow to release the moisture once that moisture gets in there. So the warranties, if you haven't ever noticed, the manufacturers will only warranty XPS up to about 90% of the R value over time, because it loses its R value over time because it won't release that moisture. And so you have to be careful of your warranties on that. EPS, expanded polystyrene. It's a closed cell rigid foam board, and it's a little bit lower in R value, but it does retain its R value over time. It's pretty good. It can be used anywhere in the envelope. A lot of people like to use EPS because it's more versatile. Graphite polystyrene, which is your GPS, right? About an R5 per inch. It does have this semi-vapor permeable, so it does allow some drying. So depending on how you want to use it, it works good for allow some drying and good in closed spaces because of that. Some people like it because it's thinner, it's smaller, it's easier to install, especially in those little small confined spaces. Polyiso, a lot of people use polyiso. I see closed cell rigid foam board. It has probably one of the higher U factors per inch and a nice thin profile. You can get fire resistance in it. It's pretty lightweight, but again, it's like the XPS in that it can degrade over time, so the warranty will only cover the R value for a certain period of time, and then it decreases. And then mineral wool, right? That's like a rock wool. Pretty good. I think we're going to start seeing an increase in mineral wool with this wildfire resiliency code coming out at us, and because there is some ignition resistance to it. Some of it is non-combustible, and so we're going to see that. It does have probably the lowest of all of them in U factors per inch, but the benefits of being able to use it for the wildfire code is probably going to be outweigh that.
Does it breathe a little better than the foams?
Yes, yes.
And then the R value is comparable to
It's
sort of popular foams.
some of them, yeah, yeah. You were going to see, I think we're going to see a little bit more of that coming out. There's some other kinds. Yeah, what are you guys seeing out there? I have a slide on that. I have a slide on what are you seeing?
Real quick,
Yeah.
have seen more of that.
More, you're starting to see more rock wool. Yeah. Yeah, I think you will. Yeah, it's very durable. It's a good product, easy to install. All right. Some other kinds, how can you get other types of continuous insulation? I could build a double wall, right? I can have a framed wall of cavity insulation and another framed wall of cavity insulation, offset them so that the studs don't line up, and now I can count that as continuous insulation. I see some of that being done. I see sometimes people like, I've seen people build like a structural wall, do all your continuous insulation in, or do all your cavity insulation in it, and then go over it with like a rock wool or something on the inside of that, and then build a small wall on the inside for your plumbing and your electrical that has no insulation. All your insulation is there, but you have a cavity and a continuous, then an airspace and a barrier, and then you have a little wall that handles all your plumbing and mechanical stuff. Like there's all kinds of great ways. If you just Google any kind of double wall, the National Association of Home Builders has great videos on double walls. There's all kinds of information on double walls. Not everybody likes it because a double wall takes, we start encroaching into our square footage, right? And so not everybody likes it, but there's ways to keep it down instead of, you might have a 2x6 wall and then a small wall just for your plumbing inside. It doesn't get too bad. Bats. Bats can be hung continuously. I see them in basements most of the time, bats being hung continuously, or crawl spaces, right? You see those big diaper bats. I call them diapers because they're just insulation in encapsulated in a vapor barrier, those white vapor barriers. They're screwed to the wall. Those screws are just fasteners, so you can still call it continuous insulation. Spray foam. What do you think of spray foam? Can you think of, I would love if somebody could point out when spray foam is installed continuously. Like, what is the, I suppose, if I had like a truss or a rafter space, right, and I filled up, if I filled up the cavity plus went even more, then a portion of it would be continuous. But I don't know.
You can do that with just like you were explaining the double wall.
Mm-hmm.
So you just had a single wider, say a 2x8
Yep.
blade, and you had staggered studs that were 2x4s or 2x6s.
Mm-hmm.
You can spray
Sure.
inside and outside.
In a double wall. Yeah.
It's a single wall, but it's staggered studs. You can do that with bibs.
Oh, gotcha. I see what you're saying. Yeah, well, a single wall, 2x8 with 2x4 studs.
Yeah,
Staggered. Yeah. I've seen, you're right. That's a good way to do it. Okay. I keep trying to picture, like, because you got to get that insulation all the way around those studs, and it's hard to do. That's a good point. Marvelous. The other one is wood fiberboard. You might start seeing some wood fiberboard. This is pretty good because they take all the wood that's left over from a construction site, ground it all up, get these wood fibers. They add some stuff to it. If they add something like borate, you get a Class A continuous insulation right there, right? If they just add some, like flame retardant or something, you would still end up with a Class B. But so we might start seeing some of that because especially for people that are going to like a green code where they can say, okay, we took the leftover wood and we ground it up and used it for our insulation. What else? What other kind of insulation are you seeing used for continuous? I couldn't think of any, but that doesn't mean anything.
Rubber to doll.
All right, so here's Breckenridge's envelope requirements, right? So we see for insulation, a ceiling R49, unless you go to the package options and you want to do that R60 because you chose the platter. R49 is the base. If you do insulation above deck, now residential has an option for insulation above deck. That'd be an R35 continuous. Wood framed walls, prescriptively an R30. If you just went cavity only, you might get that in a 2x6, but probably not. R20 plus 5, R13 plus 10, so that's the difference between a 2x6 and a 2x4, or an R20 just continuous. So that's prescriptively, those are the values that are in the code right now. We didn't amend that. Mass walls, R19 versus R21. The code always says you can do less insulation if you install it on the outside of the building, more if you do it on the inside. So that slash means R19 if you put the continuous insulation on the outside of the building, R21 if you put it on the inside. It works better on the outside. Floor insulation, R38 cavity, 19 plus 10 or 25 continuous. Be interesting to see a continuous floor insulation. Unheated slabs are 10 for 4 feet. Heated slabs are 10 for 4 feet plus the R5 underneath it so that heat goes into the building and not into the ground. Right, so what kinds of insulations are you seeing here being used in these situations? What is the common insulations for Breck? What are y'all using? You doing continuous insulation?
It's a mix between spray foam and
Spray foam cavity.
spec monitor. It's which bulb is it? Spec monitor.
I think he's just using.
Polyester.
Yeah.
Yeah.
A lot of people are spray foam in the slab too.
Yeah.
Oh, really? Spray on the fab. But you got to really make sure that you protect that from the elements. I mean, all insulation you have to make sure you protect, but some of it has a little bit of protection built in. What are you doing in an above grade wall? It's a house. You're Are you doing it like a flash and bat? You spray a little foam to get your air tightness and then you put in a bat in there? Or are you doing some cavity plus continuous on the outside?
Two corners of the room, there's guys building kind of those double walls.
Oh, we are doing double
This
walls.
crew over here has two different plates, top and bottom. This crew over here has one plate.
One plate,
Bottom,
yep.
Staggered studs.
And actually, that same developer he's talking about is going back to a 2x6 wall with nibs insulation and zip R on the exterior.
Yeah.
So it's R20 plus 5.
Okay.
It's a little bit
All
more.
kinds of ways.
I guess the thing that you just have to keep in mind, and we'll talk about here in just a couple minutes, is what's the right number to have outside the building, right, to keep condensation down? And it's, of course, dependent on the whole thing, but we're going to get into that today because that seems to be one of the big questions.
Does the code speak to continuous at rim conditions
Mm-hmm.
anywhere?
It just says the rim joists have to be insulated and air sealed, but I typically see it on the inside, so it's cavity. Right? You spray foam or maybe cut a piece of rigid foam board and but that's a cavity. It's a thermal bridge, right? Yeah.
So it's the exterior
Mm-hmm.
continuous seems to be more effective than that.
Absolutely. Anytime you can take that exterior continuous insulation over that linear thermal bridge, you're going to have a big difference, and we're going to get into all of that. All right. Why continuous insulation? Well, I mean, some of it seems like, okay, it's more energy efficient. We're resisting that heat. We're keeping the heat that we're paying to heat and cool. Heating what we're paying for inside the building, and we're not losing it as much. But you guys think about it. It has a little bit bigger, even on the energy efficiency side of it, even on the comfort side of it. On all of those sides, there's even a bigger picture. Not just in energy saving, but in cost savings sometimes, because if you think about it, if I build this really great thermal envelope with a lot of continuous insulation, not a lot, with continuous insulation, and I'm not losing that heat, and we're already required to build a tight house, right? So we're not losing all of that heat, then another nice thing that happens is I probably can drop down in the size of mechanical equipment that I use, right? Because I don't have to heat as much. My load is smaller. Right? If I calculated my load with a manual J of just an R19 wall versus an R20 plus 5, I'm going to come up with a smaller load. And the nice thing is you don't have a lot of short cycling with your equipment going on, right? Because the temperature in the room stays the same temperature longer. You're not losing it, right? So the furnace kicks on, meets the temperature, shuts off. It doesn't have to kick on for a while. Whereas if you have a lot of air leakage or not as enough insulation, you have a lot of short cycling going on, it kicks on, lose the temperature, you're always reheating. And so there's some different, all kinds of benefits that come with that energy efficiency, but also just cost and mechanical equipment alone. One thing, I was talking to Joe Stebrick a few years ago, I think when we were writing the 18 or the 21, and he said, we were writing Aspen's code and they wanted to amend out the requirement for manual J. I said, dude, I would not write that anywhere. Manual J is such a great tool so that the owner gets what they paid for. Like they're going to get the right piece of equipment for their house. And he said, Aspen builds igloos, right? Like we build such great envelopes with such great insulation that even if you oversize the equipment, it wouldn't be a big deal because, again, it's going to turn on, meet the load, shut off, and it's not going to turn on again. You're not going to have all of those issues. So, like, okay, well, I'm not going to take the speed limit sign down just because one person is going the right speed limit, right? Like, I'm just afraid to do that. We did it for a cycle. We removed it, but we put it back in. But it's a good concept, right? We have a lot of other rules going on because we weren't insulating really well. Code compliance, of course, there's not a requirement prescriptively that you use a continuous insulation. You can go R30 in your cavity if you want to, or there's options you could trade off with ResCheck or performance. So you could trade things, but you're definitely going to comply much easier and quicker with the continuous insulation in your assembly, for sure.
It seems like with the code updates, at least in our climate, it's really actually pushing spray foam insulation in the cavity R30 versus, because the continuous has to go up to 7.5, or really for zip panel it'd be 9. So
It is getting harder to do. Yeah, I mean, well, especially for commercial. I mean, for residential, what are your options? Is a R30 cavity, an R20 plus 5,
yeah.
R13 plus
Or
10.
the continuous, but it's just
Right.
seems like it's going to be a harder sell now because we have to go to such a higher value because of the vapor issue.
For the vapor issue, that's right, right? That's the key. It's not the energy code issue as much as it is the vapor issue that's going to drive you to a higher than an R5 most likely, right? That's where I think people are missing the mark, right? Is that, oh, the code just says I have to do R20 plus 5, and then they come back later, how come I have so much moisture in my building? Did you calculate that dew point? Right? So we're going to look at that for sure in a few minutes. But yeah, it is probably driving you to a higher one, or there are trades, right? You can go ERI, you can go res check, try to make a little bit of a trade, make it up in your windows. That's one thing that we have to remember, how to use those passive compliance to your benefit. The code has a lot of them in there. And so do you have to do 20 plus 5? Maybe I put in a better window. We're at 0.30. You could probably buy 0.25 all day long at the store, or 0.27 or 0.28, right? Use that better window as a trade to have less insulation, as long as you're not trading vapor, right? There's all kinds of things to think about. The code there's requirements. The 2024 went really much further in the IRC, not the energy code, the IRC, to address vapor and trying to get that. But it's really hard to write a code about the mandatory vapor requirements when there are so many different kinds of assemblies out there, right? So it's really hard to do. It leaves it up to the designer for the most part. All right, combat thermal bridging. Like I say, if we could take that continuous insulation down, we'd combat some of that thermal bridging that takes place there. Reduce moisture and damage, we're going to go into that, how we can reduce the moisture issues, and enhance comfort, right? So there's a lot of reasons. Another reason that people aren't thinking about is a lot of people heading towards building electrification, right? And so this is a battle that I had with City Council in Aspen, right? They wanted us to be all electric when we adopted that 2021, and I'm like, heck no. We got to get the envelope down first, and a really good envelope, so that when we do go all electric, we're not taking such a huge load, right? And so we have a lesser load, trying to save on those panels and those all the equipment and the utilities. And the transformers, that's the word I was looking for. So that's another nice thing about continuous insulation is, again, if we can keep this thermal envelope really, really secure and well insulated, we don't have to have as much load to heat and cool it. All right, let's look at a couple things. There's some basic principles to this. We have this, I think I've shown this to you guys before. We have the IRC that tells us how we have to build this light frame construction. A lot of us are doing light frame construction, some maybe a little more, and have to build out the IBC. But we think, okay, 1 king stud, that's probably pretty good. Structurally, that's good. If 1 king stud's good, 3 is probably better. Well, then 6 has to be really good, right? Or what about 15? Like, the pictures don't lie. But you get stud packs, you get all kinds of things that now are interfering with, that are causing these big, huge thermal bridges, right? They might be great structurally, not 100% sure they're needed, but they might give you peace of mind, I guess, structurally. But just pay attention to the 21 and the 2024 IRC, because the home builders, really, the National Association of Home Builders really did a huge effort of going in there and stripping out a lot of the excess framing that was in there. And so you don't need triple headers in a lot of places. Like they got some of that removed. So we don't necessarily need all of this, but if it's there, you're going to have to calculate that into the U factor of your wall. Because you can say, I have a wall with R20 insulation, but you don't. Not when you get to this section of the wall with 15 king stud, or with your stud pack. So you have to, technically, by the letter of the code, you have to calculate that into your overall R value and your overall U factor. Many are not doing that. Another case for continuous insulation on the outside of that wall. Right? So you can drive down the road and see all of these studs, right? You can see the framing. You can see the heat loss. Why is that? Because wood has about R1 per inch in insulation between 3 to 7. And so wherever there's insulation, you're going to be able to see that. Wherever there's wood, you're going to be able to see that. That's a lot of thermal bridging happening right there. So how do we deal with that? We put some continuous insulation over there. You're going to drive by the same house and not see any of that, right? A couple things about continuous insulation. If you're using it, maybe you can go into a ERI, or you can go into res check. The code says R20 plus 5, but I'm doing R20 plus 7, or I'm doing R20 plus 10. Use that. Anything you're doing better than code, use to your benefit, right? Don't go prescriptive. If you're doing something better than code, don't go prescriptive. Go at a minimum with res check. Res check is a prescriptive path, but at least use those things to trade off, right? To give yourself credit. You might be able to get lesser slab insulation or less something else. Not trying to get you to do that, but. So continuous insulation is great. There's all kinds of things about it. It's kind of hard to see. But here's something I ask. A lot of times people will say, man, this energy code is just getting so expensive and getting really hard to do. Like, yeah, it is, but what are you doing? Right? What are you doing? Well, we have to do continuous insulation. Okay. Then just like you would use the paths of compliance to your benefit, use the continuous insulation to your benefit. What's the difference between this house over here and that one? They both use continuous insulation. This one and this one. Both using continuous insulation. One of them is using the continuous insulation to their full benefit by sealing all the joints and seams. Because now I have a vapor, water, air, thermal. Here, I didn't seal all the joints and seams, so now I had to put my Tyvek on the outside. Right? Why you need Tyvek? You need a water-resistant barrier? Seal the joints and seams. Right? Like, it's just you're just used to using Tyvek. Okay, well, fine, go buy some extra Tyvek. But why do you need to? Right? If you just seal the joints and seams. You have a drainage plane. You have a lot of things in one product, right? So I need to use continuous insulation for thermal bridging. I need to use it to keep the moisture down. I need to do it so that I can have a smaller furnace. I need to do it, all the reasons, then use it to your benefit. One product for a lot of different requirements. All right. Do you end up with moisture in your wall assemblies? Just made sure Jess Hoover said, please cover moisture because we have an issue with it. So, how do we keep the moisture out of the walls? We have to evaluate it. Yes, like I said, the IRC will send you into this vapor retarder, that vapor retarder in Chapter 8. You might have to, what's allowed depending on what you're doing. But it's really up to the designer to look at the whole assembly plus the climate and the temperature and the relative humidity and say, here's where it's going to condense. When the cold air outside meets the hot air in the house, where in that assembly is it going to condense? Most likely on the sheathing. Do we want vapor on our sheathing? I don't think so, right? So how do we get it to move out of that wall assembly? Put more continuous insulation, right? To change that dew point and bring it out. There's a lot of ways to do it. There's a lot of ways we get moisture in the building. just water intrusion because we didn't seal it up, or we used we didn't protect our products. Air leakage, wherever air can move, so can moisture, right? Again, not sealing it up, not having a continuous air barrier. Indoor humidity. We're in a dry climate. We have more humidity on the inside of our buildings a lot of times than on the outside, so we have humidity that can get into the walls because we didn't seal the outlets or because we didn't seal something up, right? So we can get it that way. Construction moisture, we put in wet wood, wet drywall, and water vapor. How do we deal with water vapor? If you haven't seen dew point calculators, you need to, right? We need to be checking those out because of the way that we're building. We need to make sure that we're keeping that dew point away from the sheathing, right? So if you look at this, this is another great website for you is constructioninstruction.com. They have a facility in Denver, but they also have a free app for anybody, and it is the most amazing app about how to install anything in the envelope. Vapor barriers, air barriers, windows, just whatever. They have all kinds of building science videos. They have all kinds of things. But on their website, they have, their own dew point calculator, just like a lot of people do. But I like this slide because it just kind of gives you, an idea based on, this is out of climate zone 4, so it's not like, it's relevant to us here, but it's the idea of how it works. What is your climate zone? How are you building? I'm building in climate zone 4, a 2x4 with R13 only, cavity, right? No exterior insulation. I calculate the temperature, the time of year. My dark blue line is my mean annual temperature. My light blue line is that dew point. This is where my dew point is going to hit so in these times of year, below the pink line, I'm going to condense on my sheathing, right? How do I keep from doing that? I have to make sure that I have to add some continuous insulation. How much depends on, what you're doing in your climate. But you can see here, they just added an R5, brought their dew point, they're above the line. They're not going to have condensation on the sheathing. So it's super important that gets figured out. Is an R5, that was just in climate zone 4 with a 2x4 R13. We're talking most of the time a 2x6 with some 20 or 21 or whatever, right? Maybe a 5 will work, depends on what we're doing. But you got to calculate that. Are you finding that R5 is enough to keep the dew point? Or have you ever looked? That is not something that is a code requirement. You're not going to find it in the code. The code's going to tell you put a vapor barrier. Where are you going to put it? How many of you are putting a vapor barrier on the outside of the building and the inside? Right? If I use my continuous insulation and seal all the joints and seams, what is that? A vapor barrier? And then I'm going to put one on the inside? How's the wall going to dry if it does get wet? Well, hopefully it'll never get wet. Well, how are we going to know if it's going to get wet? We're going to calculate the dew point and figure out where that's going to be, right? If I have it down here in the pink, and I have a vapor barrier on the inside because it said to put a vapor barrier on the warm and winter side in my climate, and I have a vapor barrier on the outside, and I condense inside the wall, I have no way to dry. I have nothing but mildew and rot. Right? I have to calculate the dew point so that I know. If I have this situation, I can put a vapor barrier on both sides. It doesn't matter. I've moved my dew point to the outside of that wall. So just some things to think about. There are a million dew point calculators out there, right? Everybody has one. These are just some good ones that I like to use, but you could just Google dew point calculators and you're going to find a billion of them. I will make sure, like I said, I'm going to give you a copy of this entire presentation, all the links, all my resources. Some of them I have saved as PDFs so that you're going to get them. I didn't want to print them out because some of them are 50 pages long, and I don't know who's going to want what, so I'm just going to send them to you and you'll have them. But this is super important to make sure that you're calculating that dew point. All right. little bit more on continuous insulation. Make sure I'm doing good. All right. This is, we talked about how continuous insulation can be used as a vapor barrier, an air barrier, thermal barrier, a water resistive barrier, as long as you pretty much seal all the joints and seams. Is there anything else I need to know about continuous insulation and its install to know if this one kind, we have XPS and EPS and poly and, we have all these different kinds, can they all be used the exact same way as all those different materials? Every single one of them will have an ES report, right? If you haven't pulled up ES reports, this is something you ought to do too, besides the dew point, right? Check out, ICC has an evaluation services where people can bring their products, have it evaluated to code, and it's costly, so not everybody does it. Some of these ES reports are broad. They cover all polyiso. Some of them are proprietary. It covers polyiso by this manufacturer. So you have to be careful of what you're looking at. But they evaluate it to code, and they go through and say, it can be used as this if it's installed this way. It can be used as this if it's installed this way. So I just want to kind of go through them a little bit, right? What are the uses? This is for, who's it for? Thermal insulation, roof deck insulation, and a water resistive barrier for insulfoam. Right? I have this insulfoam product. Can I use it as those things? They're evaluating it for those three: insulation, roof and deck insulation, and a thermal and a water resistive barrier. So here's my uses. If I blow that up, right, I can use it as, I can have it for cavities, I can have it on the roof, I can have it for slab edge, I can have it certain things. It meets the code. Then it goes on here. If I put it on a wall in an attic or a crawl space and no covering is applied, then it has to meet these requirements. It'll always tell you, do I have to cover it up? How do I have to screw it on? Where is it allowed to be used for? And so it gives you all the uses, and then it'll go through and say, okay, here's how it has to be installed, right? If you want it to meet thermal, you install it this way. If you want it to meet water resistant barrier, it has to do this way. And it goes through all of it, right? What thickness it has to be, all kinds of how far it can be penetrated, and all kinds of information in there on how it has to be installed. And then if you're going to use it, oh, by the way, if you're going to use this in a crawl space or an attic, you need to know these things. Right? And if you're going to do it, you want to use it as a water resistive barrier, fine. We're evaluating it. It can be considered a water resistive barrier if. Right? And so you need to make sure that you're really familiar with that, because not every manufacturer and not every product can be installed the exact same way to achieve the exact same thing. Right? So another thing it has on there are some installs. Notice, you go, okay, it will tell you what's the screw pattern in the field and on the edges, all of the stuff. It'll say, here, 2-inch PolyGuard 136. Well, if it says that, that is what you have to use, right? Whenever it lists a proprietary name, that's how it was tested and that's how it has to be used, right? Unless somewhere in the little fine print it says or equivalent. But just know that there's a lot of, these are great. They make ICC ES reports for every product out there practically, right? People want to know, can I use this in my building, from plumbing fixtures to wood. And so you just want to make sure, especially drywall or anything in a rated assembly, is very, very particular on if there's a proprietary sheetrock or some of it will call out a rock wool, and it has to be rock wool, right? So you have to pay attention to those. If it says or equivalent, then you're okay. So just know, use your ES reports.
We've used that service, Philip's good at that.
Yeah?
Some roofing underlayment.
Oh, yes.
Sort of litigious situation, and that really helped him out.
Yes, it's great. I think people don't. We're just so used to just seeing rigid foam board, and you just see it installed everywhere. You know, like or products like or an underlayment. They're all the same. They just make sure we seal all the joints and seams. They're all good, but they're not all the same, right? And so.
Product claims to meet the
Right. Show me the money, right? Like show me the ES report. Yeah, so, and there's, I mean, another thing is, everywhere in the IRC and the IBC, there's testing, like, okay, this has to be tested to this standard, and this has to be tested to that standard, and you'll get something that'll come in and say, it's tested to CA, blah, 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 and you're like, oh, the code doesn't allow CA. It only allows, NFPA or ICC or, like it'll ASTM or whatever. It'll only allow these. There's a lot of Canadian ones that the code doesn't allow, but you'll see a product come in, yep, it passed Canadian test, blah, blah, and you're like, okay, it passed the test. If you look in the code book, it doesn't allow that test, right? So you just have to be careful with it. I think we take a lot for granted. We just don't want to get to the end and end up with moisture in our buildings or something just because we didn't install it the correct way or follow the right test. All right, the hot topic of the day is wildfire resiliency, right? This is the code that the state required, the wildfire resiliency code, to be adopted by April 1st for every jurisdiction, every fire jurisdiction, every fire district, every building department. Everybody has to adopt this wildfire code. And people are like, how does using continuous insulation, can I still use continuous insulation? Is the energy code going to conflict now with the wildfire resiliency code? No-ish. You're just going to have to change the way you build, right? And so we'll look at that. We're going to look at that. I will take this second to put a little plug in for my man Phil over here, who is now on that wildfire resiliency board. So we get some good representation now going into that board, so I'm super excited about that. All right, so let's look at that. I know this is really, really small wording, so I'm going to hopefully help you. I had to put it all on one slide just so I could show you what it's talking about. When it gets into the hardening requirements, it says that we have to build exterior finishes. We need to, resist these wildfires. How do we do that? And they're not going to come in and say, thou shalt build your buildings out of concrete. Everybody build out of concrete? We're good. No. So they say, okay, you can either do an exterior wall assembly with a minimum 1 hour fire resistance rating from the outside, exposure from the outside, approved non-combustible materials, heavy timber or log wall, non-combustible materials complying with 4022 from the exterior side, fire retardant treated wood, ignition resistant, except, and then it gives you some exceptions. How this is all about, most of it is evaluated from the exterior side. How do I get continuous insulation in there? Can I use my vinyl siding? This came up last night. Can I use my vinyl siding, right? You have to go down here to exterior wall covering, and it does tell you non-combustible materials. Exterior wall coverings are limited to non-combustible materials, fire retardant treated wood, or ignition resistant materials. There's a lot of ignition resistant insulation, but you're going to have to pay attention now, right? But there's a lot of ignition resistant insulation. But then there's an exception here. If you use option 1 or 2, a 1 hour assembly or non-combustible materials, now you can use your vinyl siding as your exterior cover. So you still can use it, you just have to build 1 hour or non-combustible, right? So there's different ways to do it. You're going to have to look at which one are you willing to build. That's going to tell you what insulation you can use and where it has to go in the assembly, right? If you're going to do a 1 hour assembly, what insulation is that? That's usually in all 1 hour assemblies. Like a rock wool, right? So you might have to change the insulation you use, but you can still use your continuous insulation. So just want to, there's a lot of information out there. One of my favorite dudes in the world, Joe Breck, he's just so funny. But he has buildingscience.com. You'll get these resources. But he has been talking about wildfire resiliency in construction forever, right? And so on their website, they have, if you've never signed up, go to buildingscience.com and sign up to just get their newsletter or their BSIs, their Building Science Insights. He sends them whenever he gets a wild hair, and they're usually funny but technical, right? So he's talking about rocks don't burn and how you can build this assembly. I like it because he says in the middle of all of his technical jingle over there, he's also saying, if you take a rock and you melt it down and you blow air through it, you get a fluffy rock. Fluffy rocks don't burn. If you take gypsum and make it into sheets, you get sheet rock. And guess what? Rocks don't burn. Also, metal doesn't burn. You can look that up. Okay, well, metals do burn, but you get the idea. If you take wood, which burns, and add rocks or metals to the wood, you get wood that doesn't burn, right? This is just his sense of humor in trying to get stuff across to you, right? And so he says, we could be onto something here. There's all kinds of places where we have to deal with wildfires. More even so now with the changing of our climate. And all kinds of places where you build right next to your neighbor. Where we build next to our neighbor, we have kind of decided that it's a good idea that if our neighbor's house catches on fire, ours doesn't, and so, or vice versa, you know. And so he's like, these are the things that are in this technical document as you're reading through. But he goes into, you know, how embers do this and how radiant heat does this and whatever, and gives you all kinds of great details on how to do it. Here's another one he did. I mean, like he wrote this like way back, like I think it was like 2011. Like wildfire is not a new concept. And so here's another one he did with a different assembly, right? And talking about that, more combustibles versus fire retardant treated, or like all the different kinds of ways to do it. So that's a good resource for you. Another great resource I hope we have time to look at when we're done is this continuousinsulation.com, or is it .com? .org. .org. And if you click on applications and you pull up fire performance, you're going to get everything on there, all kinds of details for those fire rated assemblies and how things work, how to meet NFPA 285 if you're doing a commercial building. So all kinds of resources there. Rock wool. They've been rock stars lately. I watched a webinar they did. They've put out some amazing materials on wildfire. They have this building with rock wool, stone wool. You're going to get this whole thing, but it's amazing. They give you all the different details that you can use on your plans. Give you the plan set, you know, what about at a windowsill? What at a door jamb? What do I do at a, you know, and they have all the details right in this thing. It's pretty cool. Another good resource is FEMA, Builder's Guide to Construction in Wildfire Zones. This is pretty good. They go into all the different kinds. You have a wildfire, some of it's going to be ember, some of it's going to be radiant heat, some of it's direct flame. What do we do? What are the experiences? What have we learned? Right? They also have this cool website that it breaks it down. You know, what are the different kinds of disasters that hit us, and they have guides through them. But I thought this map was kind of cool. It's kind of hard to see here, but the dark blue, let me think if this is the light blue. The light blue is states with statewide code enforcement. The dark blue is statewide codes but not being enforced, which is a bummer. And black is no statewide code. Like, we don't have a statewide code per se. We're getting there over time. But, and so that's what that means. Then the yellow is hail. This on mine, it looks more yellow. This is hail, this is hurricane, this fires, wildfires. And it just shows you the incidence of wildfires and where you can see them. And they track that by year and everything. This is the insurance industry putting out all this information. So this is another great website, the insurance industry. They're becoming more and more involved, and I know that they're getting involved now in the state's wildfire code and putting out more resources about things. There also, I heard last night, talk of the insurance industry putting out their own wildfire code that if you want to get insurance, you're going to have to use theirs, and it will be more restrictive than Colorado's. So this is not going away. We're going to have to learn how to do this. We have to learn how to build wildfire resilient, vapor resilient, thermal, like they all go together in how we build, and it's just going to change how we build. But it's not going to go back. It's not going to go backwards. Yes, there's some lawsuits and some things out and some legislation to remove it all. But is it going to go back? It would be really hard, especially when you have the insurance industry coming out saying, we're going to put out our own wildfire code. It kind of gives you an idea that this is not going backwards. Even if the state repealed it, you're going to have an insurance company, the insurance industry bringing it to you. So it's not going to go away. We just have to figure out how to build the right way or differently. So, all right, finishing up on continuous insulation, just some things to avoid, some common pitfalls that I see while we're out there is you have to make sure when you're doing more than one layer that you're staggering the joints. Right? If you just put 2 sheets of insulation on top of each other and you don't stagger the joints, you build this cavity there, right, where things can happen. And so you have to stagger the joints, seal everything up. Be mindful of materials that conduct heat, such as metal fasteners, structural elements, those things, so that we're dealing with the thermal breaks, which is our next section. Make sure you're identifying all those wall penetrations, the plumbing, all of the stuff, and that it's getting sealed up as well. Make sure you select fasteners that are compatible with the insulation and incorporate proper flashing and moisture barriers. Also, for designers, calculate the darned dew point. Right? You're going to need to do that. Also, don't rely on foam sheathing as your structural sheathing. There are some insulated sheathings, but the foam sheathing by itself, the foam by itself is not a structural wall bracing material. Don't rely on foam board for wind resistance, right? That's the structural aspect of our building, not the insulation's job. Okay, make sure you're referencing IRC 316 or IBC chapter 26 to understand how we're allowed to use foam plastics in buildings, when it has to be covered, how it, and all of those kinds of fun things. And then check out, if you haven't, and maybe this is something that you guys are using, they have this new Appendix BN in the IRC that is extended plate walls. So you have it's basically a prescriptive method of creating a wall that has maybe it might have an 8-inch plate with a 6-inch wall. So that, and then you can have your continuous insulation. It's just a prescriptive way of doing that. It's pretty handy. I don't see a lot of people using it, but I mean, at least they're trying to come up with ways to make continuous insulation be easier to install. All right, another thing, don't do drive-by inspections. This was the house I was at in New Mexico, and I'm like, oh, I don't remember the plans calling for continuous insulation. I thought, wow, they got continuous insulation. It is not. It is blue painted sheathing. I thought it was continuous insulation. It was actually fluid applied air barrier, right? But from afar, I thought, wow, I've never seen a house in New Mexico do continuous insulation. I'm going to go look at that. Yeah, it wasn't. Right, so don't do drive-bys. Okay, never know what you're going to find out there. All right. We're going to jump into thermal bridging because we brought this into the code. The 2024 brought thermal bridging requirements in for commercial buildings. Breckenridge has, like many other jurisdictions, also brought that in for residential buildings. And so we're going to talk a little bit about that. What is a bridge? A bridge is a way to get from there to here and transfers that material. If it's a thermal bridge, we're talking about heat loss, right? We're heat going from inside to outside or vice versa, going through the wall assembly. and trying to stop that. And where does it happen? There's a couple things to know about thermal bridging. It definitely, you're supposed to be, when you say I'm doing an R30 wall, that is supposed to include thermal bridging into the calculations. When you say I'm doing a U factor of whatever, it's supposed to include thermal bridging. I don't see that very often, but it's supposed to. So here's an idea for you. An R19 bat is only R19 until you put it until you install it, right? I install an R19 into metal frames, I'm effectively getting an R7.1, and that's if it's installed well. And I put an R19 into wood, I'm getting about an R16 for that wall assembly. And so because of, what are we at? R1 per inch versus the R19, the whole wall ends up dropping down. That's if it's installed good. You start having gaps in compression, it brings it down even further, right? So the code is trying to get you to think about where we have some thermal bridging taking place. It's not going to tell you don't install metal or wood, right? Like it's not going to say that, but it's going to, there's a couple places it's going to ask you, especially metal, huge conductor of heat loss, right? Metal. And so if I have certain places, do I think about how I'm going to lose all that heat loss through that metal, or did I put a thermal break in there so that heat goes back into the building and stays where it should be, right? And so that's what we're trying to get you to think about. Yes, wherever you have a stud, you're going to have heat loss, but there's other places we're going to have even more heat loss. I have some jurisdictions that require, you can't trade out of continuous insulation for the thermal bridging aspects of it. There's all kinds of ways, we see floors that run continuously or slabs that run continuously in and out of the building. It's taking that heat with it. And so what do we do there? There's all kinds of places that we have thermal bridging. A cool resource for you, again, continuousinsulation.org, where if you look in there, you go to applications and you choose thermal bridging prevention. Lots of details on thermal bridging details are in there, right? And how it works and how to mitigate it. So we're going to see some of those today. Let's just check out what are Breck's requirements for thermal bridging. Okay, doing good. All right, Breck, residential thermal bridging. Thermal bridges in above grade walls must comply. Some exceptions. Any thermal bridge with a material thermal conductivity. If it doesn't have a lot of conductivity, and we're okay. Use it, right? You don't have to mitigate that. Blocking, coping, flashing, and other similar materials for the attachment of roof coverings and thermal. If you already account for that thermal bridge in your overall U factor of your wall, you don't have to worry about it. How many of you are accounting for the thermal bridge in the overall U factor of your wall? Yeah. Okay. Here's the requirements. It's not required everywhere, but balconies and floor decks. For sure, we're going to look at balconies and floor decks because that is a big, huge linear thermal bridge, right? Balconies and floor decks. Balconies and concrete floor decks shall not penetrate the thermal envelope. Assembly should be separately supported or shall be supported by approved structural attachments, and then there's exceptions, right? Do it as long as you have an approved thermal break. There are ways to do it. We're going to look at that. There are a lot of different kinds of thermal bridges. A field thermal bridge is like something of the whole thing, like maybe those Z panels that would affect the thermal bridging of the whole wall. There's linear, like at a floors or decks or patios or something like that, and then you have point thermal bridges. So we're trying to right here at the patios and stuff deal with this linear thermal bridge. It's a line across the whole building that has thermal loss in it. How are we going to deal with that? We're going to look at some details for that. There's all kinds of ways. There is a huge thermal loss there, and so we're going to try to deal with that, right? Slab floors, balconies, shelf angles, all kinds of things I like this. This is in that thermal bridging details document on continuousinsulation.org. Depending on the quantity and detailing used, the heat flow can account for 20 to 70% of heat flow through the thermal envelope. That's a huge amount of heat flow that we're losing right at that balcony or that deck that's going through the building. So we have to mitigate that. There are a lot of ways you can cut your, you can stop your floor here and then add another floor here, or you can put, they sell these, they sell some thermal bridges there. You have to figure out what's going to work for you, but there's a lot of different ways you can do it, but you have to now provide a detail with your building plans how you're going to deal with that thermal bridge at those balconies and decks. Right? That is a requirement for you, and your construction documents need to provide a detail. You're going to get a checklist that says, yes, I provided that detail, right? So that you know what you have to provide. Cladding supports. Cladding supports, it says, linear elements supporting opaque cladding shall be offset from the structure with attachments that allow continuous insulation to be continuous, right? Not Z strips or any of that. We're going to have unless you have an approved design where the U factor is accounted for, you're going to see some similarities in that. Also, structural beams and columns. This is like a point bridge, right? Where we have a structural beam or column here that's I'm transferring through the envelope there at that one point, and how am I going to deal with that? How am I going to mitigate that, right? There's all kinds of, it could be a pipe, a beam, a column through the envelope. It can also be fasteners. A fastener could be, if it's a fastener and not like a Z-strip, but if it's a fastener, you could call it a point, but if it's a ton of them, it could be a field thermal bridge. And the reason I just throw those names out there is because there are details for how to mitigate each one of those in here, right? So I'm just high level telling you what they deal with, what you're going to have to show us. How did you, if you had a column hitting there or a beam or something, how are you dealing with the thermal bridge at that point? There's all kinds of ways, and we'll just keep going. This is what I want to talk to you about. I remember when I said, if I had that wall, and I put R20 on the inside, and I put R5 on the outside, but on the outside I use those Z strips, and so now that's cavity and not continuous. That's an R25 wall, right? I can add up the layers because there's no air movement, right? So I have R20 plus 5 is R25 because they're both cavity. If I put R20 and I just use fasteners for the R5, now I have an R20 plus 5. They're different, so you can look at this formula here. You can see if I go through all the layers of this wall, an R25 wall gives me an effective R value of R19 when I'm all done. An R20 plus 5 gives me an effective R value of R22. Right? So because I have more, I don't have as much thermal bridging. This R19 reflects the fact that I have thermal bridging there because I have those metal, I only have continuous and continuous. I mean, cavity and cavity. I don't have any continuous insulation. So you see, the code will start going more and more. In fact, it has started in 24, trying to get you to think about your walls as U factor and not R value, or any of your assemblies as U factor and not R value. It wants you to not just think about the insulation you put in it, but all the layers. The sheetrock, the air, the air film, the studs, whether it's metal or wood, whether it's 16 inches on center or 24 inches on center, all of those make a difference in that overall total R value or U factor of the wall. I want you to start thinking of things as an assembly. It used to be in the 21 and before, you had the R value table or the alternate U factor table. In the 24, you have the U factor table and the alternate R value table. It wants you to start thinking of the entire assembly, how it goes together. And you want to think about that too as we get into, wildfire and how it makes us build, and dew point and how we have to do that. We need to be looking at every layer, how it all affects each other, not just throwing stuff at it. So, but you could see. I didn't have continuous insulation. I do have continuous insulation. A huge difference in that overall effect of that building. All right, and another thing to think about is there's some different fasteners. Even if I just have a fastener, this is I'm allowed to have a fastener and still call it continuous. But they have new fasteners out there that will even take that thermal bridging down, because they have like plastic or different lengths and stuff that will help mitigate that too. If you really want to get into the thermal bridging, and I don't want any thermal bridging. You can go to that level. This is a great tool that is on that continuousinsulation.org website. It can calculate. It's called the wood calculator, but it does so much more. You tell it what climate zone you're going to be in. You tell it what cladding you're going to put in, what R value you're going to put in, how thick your sheathing is. It's going to come up here and tell you, do I comply with code? What do I need to consider on my vapor? Do I need more insulation, less insulation? Where's my dew point? And, all kinds of fun stuff. And so that's a nice calculator on there. They have wall bracing calculators on this continuousinsulation.org. They have all kinds. It's not just about continuous insulation. So it's an amazing resource. This is also a great resource for you for mitigating thermal bridges. This is the Building Envelope Thermal Bridging Guide. So a really cool guide. It goes into how to start mitigating a point thermal bridge, a linear thermal bridge, a field thermal bridge, and how to do it. When you encapsulate something, how you can do it. It also gives you, so you can see, mitigate concept of a point thermal bridge, a linear thermal bridge, and then it also gives you examples. What is a linear thermal bridge? It's more than just a floor intersecting a wall, right? Offset a brick shelf angle, offset furring, fenestration interfaces, floor edges, foundation edges. They go into pictures of, instead of building your deck through it, build the deck on the outside of the building so you don't have that thermal bridge through the building, right? I see this too. When you build I think I might have a picture of it. Instead of building a porch that is, open to the inside, you build your wall and then build the porch or the roof cover, or, the patio cover or whatever. It's just wanting you to think about adding these things after the fact instead of penetrating the thermal envelope for them. And so it's a great guide. It gives you all kinds of different kinds of thermal bridges and how to mitigate them. You could use those details, right? When you have to turn in your plans to the building department and it says, check, I provided a detail of how I'm going to deal with my thermal bridge at that balcony. You can grab one off of here if it fits, or at least get an idea of it. And so we'll give you a lot of resources for that. Buildingscience.com, continuousinsulation.org, this one. There's all kinds of resources that give you details for mitigating that. Right, this is how to do examples of proprietary thermal bridges. This is like, okay, if you're going to run it through the building, there are some there's some thermal bridges you can buy that you can install to deal with that, right, to block that. It might have some insulation installed in it, then you pour your concrete or whatever. So there's things you could buy if you want it, if you're just absolutely set on penetrating the thermal envelope. All kinds of great things in there, how to calculate that thermal bridge if you want to include it in your U factor so you don't have to. What this would say is, if I calculate the thermal bridge into my U factor of my wall, now my overall wall has to meet that U factor that's required by code, and I don't have to provide the thermal bridging details because my overall wall U factor met it, right? So you either calculate it in or do it separately and provide the detail of how you mitigated it. There's some great, these are just resources I'm just showing you, like, they have these pictures in that guide that say, okay, here's a poor install, uninsulated, has a huge bypass there. Here's a regular one, what we normally see. Here's an improved one with a thermal break, and here's a really efficient one. Like, it gives you all kinds of different situations and how to mitigate them at a window, at a glazing transition, at parapets, or whatever. And so it's a really great resource for you to use. Another one that I used early on when I was dealing with thermal bridging was this Shocks guide for analyzing thermal bridges. It's a lot more technical. It doesn't have pretty pictures like all the other ones and handy details that you can use. It just goes into what is a thermal bridge and how do you calculate it. But it's another resource. All right, I want to see if we have questions. I wanted to leave time for us to go through those websites and really show you how to find the resources, because they are amazing websites. So, but before I do that, let's just talk. All right, continuous insulation, yes, it's more expensive, but is it really? If it could take the place of a few different products, it's all one install, and you don't have several different installers, you don't have several different products. It can, adding just the right amount will save on your moisture issues. Doing the right kind is going to help you with your wildfire issues. So, I think it's one of those things that we're just going to have to get used to, is this continuous insulation idea. So lots of different things to consider, one product to solve the problems. This is going to be a list you're going to get of websites and tools, and I'm also going to give you a folder with a bunch of things in there. But this one is, these are my favorite websites. I love buildingscience.com. I use it all the time. Designers, this is a really good one because you can just go pull those details off of there. Same, continuousinsulation.org. We're going to go through that website. Construction instruction. Hopefully we'll go through that website too. That IBHS, that's the insurance website, and what they're up to and what you can expect coming at you. And then a lot of the rest are just, and you have the, I think I have in here, yeah, the Wildfire Resiliency Code Board. You can find what's the code coming at you in April. Or April 1st is when we have to adopt it. It has to be effective within 3 months of that, so no later than July 1st. Breck has already adopted it. It's already in effect, right? So, yeah, so you guys can see that. But there's all kinds of great websites up here that we're going to try to go through a couple of them. But before I do, I just want to see what are your questions? What are your concerns? What did you, like, I don't believe you on something you just said, or hey, I didn't realize that on something you just said?
So back to the vapor control issue, I thought the 24 codes did stipulate minimum continuous insulation values based on stud and climate zone and vapor barrier type.
They do, but it's limited. Like I say, there's so many different ways to build that it's really hard to write this prescriptive requirement. There are requirements in there in Chapter 8, right, like on vapor barriers and insulation and things, but because some people will trade things out, and I'm not going to use continuous insulation, then I'm going to use one of these other vapor barriers, and it just gets tricky, right?
So is there a provision in the code, like when you use the calculator on continuousinsulation.org, it's factoring in the siding you're using, every wall, and you can factor in degree days instead of climate zone. And you can make an R6 pass, but the code says R7.5. So is there
prescriptively?
Right. But so you can look at the whole assembly and solve that problem.
Yes. Yeah, I mean, they had to go in there. They have a prescriptive requirement in there that gives you, like, you have to do these as a minimum, or you're not going to make it work, or you're going to end up with vapor issues. But if you could go in there it's calculating very roughly, right? And so if you can go in there and do a more in-depth calculation and show me that you can get away with an R6 because you did a way more in-depth calculation than they did, why wouldn't you use that, you know? The things that are in there, Joe Stebrick with buildingscience.com, Building Science Corporation, I guess, he is very involved in those vapor, getting the vapor parts into the code, and Robbie Schwartz, who works with me a lot, very involved in getting those into the code. And so, you know, you can only get so in depth. Otherwise, you'd need a wheelbarrow to carry that code around. I mean, it's already getting, that IRC is already so thick, right? Like, so it's a lot of prescriptive, but if you can go get out of prescriptive and you could show your calculation, you're absolutely welcome to do that.
So from a plan review standpoint, like if we use that method, we print out that 8.5 by 11, put it on our section, that's acceptable.
For if you use the prescriptive value, the prescriptive out of the code.
I thought that was kind of what you were doing.
Yeah, if you use your own calculation of the U factor, like I think in those dew point, most of those people that have the dew point calculator also have R value calculators in them. There's a free one that that Ecotrope put out. There's all kinds of R and U factor calculators that are separate from dew point, right? That you can use that calculate every layer of the wall. And so, but you'd want to throw the vapor and the dew in there, right? You got to have it all. But if you could show every single layer of that, and that you came out with an R6 continuous versus the prescribed R7.5, because they didn't do as detailed because they don't know what you're building. They're assuming, you can see in there, there's assumptions, right? A 2x6 and a drywall and a sheathing. It's like, it's the assumptions that are in ResCheck, right? Like a certain percent framing factor. You might have more, you might have less, most likely more percent framing factor, right? And so if you can be more detailed about what you're really doing, then that's what I would accept, right? Because that's taking an assumption just like ResCheck does.
Breck would accept that.
The crux though is like the framing factor, you know?
Yeah.
You know, you're gonna kind of make
Right.
it
You are.
take a guess.
You are. Like ResCheck makes a, you know, between a 20 to 22% framing factor adjustment, you know, and so you might have more.
Do those calculators take into consideration like wall to window area?
Some of them do, yes.
You know, that's another big.
That's another one, and you guys are held to 30%.
Houses,
You have a 30% max, right, of window to wall area. So, yeah, you just got to find the right one. There's some, the one that I think, the one that Ecotrope does, and the one that not PNNL, but I'll make sure that I include it. I'll make sure that I include. There's a couple really, really good, thorough ones that I'm like, if you would use these, I would totally take that calculation. What else?
Yeah, we have 30% max fenestration, but you can get around it by doing the zero energy.
Yep, you could go zeros.
It being above code and just has checks and balances where you can weigh that out.
Yep.
Extra credit in some areas where you're getting less credit for fenestration going over 30%.
What I think that you're going to find is it's going to be most beneficial and cost effective to go either ZERS or go ERI. A lot of people, I hear all the time, just tell me what I have to do and that's what I'm going to do. Give me a prescriptive requirement. And we made those. We made them for you. You got a platters. You got, you know, you got all that. But then you have to, you really have to think that, man, I'm doing something over here that I should really give myself credit for. When you go prescriptive, you get what you get. You don't throw a fit, right? Like this is what you, minimum of what you have to install. If you do better, great. If you don't, whatever. But if you go performance or ERI, or even with just start with ResCheck, or go with one of these other programs, and you take the time to go through R408 and figure out your point system, you're going to end up with more flexibility and a better, you know, better chance of meeting the code your way But if you want to be told what to do, sure, they're in there. You do that R60 or the 49 with a third party, you do 30% windows, you do your, you know, whatever, all of the requirements that are in there in that platter, the small platter.